We'll start with conformational analysis in stereochemistry. So there are various types of stereoisomers, configurational isomers, and conformational isomers. In configurational isomers, we require to break the bond and make new bond. Bond breaking and bond making is required to convert one configuration to the another configuration. But in conformational analysis, they do not require to break the bond. Here only we rotate around the single bond. In conformational analysis, in a carbon chain, there is a rotation around single bond. Consider the simple molecule type of X, A, B, Y, in which there is a rotation, the angle between the X and Y, that angle is known as the dihedral angle. So due to change in that dihedral angle, so there is a formation of various stereoisomers of the X, A, B, Y type of molecule, that there is involves and rotation around the single bond. For example, if you rotate by 90 degree, so there is this conformation is formed, right? So when we rotate around single bond, every rotation by certain angle, we get the new conformation, right? So for such a molecule, so there are infinite conformations are possible, right? For example, if you take the ethane molecule, example of ethyl molecule, so CH2 molecule, so that molecule is shown by the Newman projection formula. In Newman projection, so if you see this is the front carbon, this is front carbon, and this is the back carbon, right? So here we can see that two hydrogens are completely look like overlapped on one another. So therefore here the angle between these two hydrogen, carbon, hydrogen, right? Hydrogen, carbon, right? And another hydrogen. So there is a simply, right? So here if you see hydrogen, this is another hydrogen, these are two carbons. If you see, in between these two hydrogen, bond angle is 0. In between these two hydrogen, bond angle is 0. This dihedral bond angle is 0. If you rotate this hydrogen around this single bond, continuously there is a change in dihedral bond angle, and we can see in case of ethane, we can see that this is the ethane structure in a Newman projection, right? So if you rotate this one, if you keep this first carbon as it is and rotate the another carbon which is behind, right, by certain angles, right? If you rotate it by 60 degree, right, you can see that these two hydrogens are 60 degree away from each other. At center you can see here there is a 60 degree angle is formed between two hydrogens, right? Therefore what happens here, due to dihedral angle, so there will be a torsional strain between these hydrogen and these hydrogens look like completely overlapped on each other. So therefore there is a torsional strain will generate, and due to that torsional strain, the energy of the molecule will rise. We know that if molecular energies rise, then the molecule will be unstable. If you rotate this by 60 degree, these two hydrogens are away from each other, and therefore the torsional strain or whatever the energy of molecule will decrease. So this is the eclipsed form, Newman projection, and this is the staggered conformation, right? This is the eclipsed conformation and this is the staggered conformation. In staggered conformation, two hydrogens are 60 degree away from each other, so therefore torsional strain will decrease. Therefore energy of molecule, you can see in energy profile diagram, energy of molecule will decrease. If you see from the, if you decrease the angle continuously, here angle is going to increase and energy is continuously going to decrease up to certain point, right? Up to certain point. Again, if you see, again you continue the rotation, these two hydrogens will come closer. These two hydrogen will come closer. Therefore, what happen? Again, there is torsional strain will increase due to now bond, actually rotation bond angle is increasing. Here angle is increasing, but this the bond angle between these two hydrogen is decreasing. Therefore, again energy will increase due to strain. So strain energy will again increase, right? Again, what happened here? This is the eclipsed form. Again, if you rotate, there is a formation of again staggered form. Again, there is a formation of eclipsed form and staggered form. This will continue up to, if you rotate, 360-degree. So these are all stable conformations, certain conformations, right? Here we have shown only unstable and stable conformations. Other than these conformations are also possible. So keep in mind, in case of conformational isomerism, so there are numerous conformations are possible, infinite numbers of conformations are possible, right? So we have seen by using the example of ethane molecule. If you see the butane now, in butane we have added one more bulky group, we have added two CH3 group. Now energy of this butane molecule is different than the energy of ethane molecule, because we have here two CH3 group. We know that as bulkier nature of group increases, the torsional strain energy will increase, because look at here, in eclipsed, completely eclipsed structure, completely eclipsed form, we can see in completely eclipsed form, the angle, the dihedral angle between two CH3 bond, two CH3 is 0. So here they are completely look like overlapped on each other. So therefore there will be more torsional strain and more energy will be there. Again, if you rotate this, we have different conformation, right? This is the staggered conformation. This is the staggered conformation. Now again, if you rotate, now what happens here? These two CH3 are 60-degree away from each other. These two CH3 are 60-degree away from each other, right? Now again we can rotate this two CH3 away from each other. We can keep front carbon as it is and back carbon we can rotate. If you rotate this, we can again, there is a change in angle, right, up to 120-degree. If you rotate here, again this 2cs, again this 2cs3, now these two CS3 are 90-degree away from each other. Here we can see these two CS3 are 120 away from each other. Now this CH and CS3 are here look like overlapped, Now there will be strain due to H and CS3 as compared to CS3. Here both are bulkier. CS3, both the CS3 are bulkier. So therefore there will be more strain. As the bulky nature of group increases, strain energy increases. Keep in mind here these two CS3 are there overlapped on each other. So therefore as the bulkier nature increases, energy increases. We can see comparatively these two and these two. This is also eclipsed form, right? Yes, this is also eclipsed form. This is also eclipsed form, and this is also eclipsed form. This is also eclipsed form, and this is also eclipsed form. Both are eclipsed, but you can see the difference in energy. This has more energy, and this has less energy. So we know as the energy of system decreases, stability increases. So therefore, as compared to this eclipsed form, this is completely eclipsed. This is completely eclipsed form. As compared to this form of butane is more stable. This form of butane is more stable. Of course, both are eclipsed conformation, but this conformation is more stable because here torsional strain is due to CS3 and H. Here torsional strain is due to 2CS3. Torsional strain is due to 2CS3. Strain is due to CH here H and CS3. H and CS3. You can see here energy is 3.6 kilocalories. Energy is 3.6 kilocalories per mole energy is there. Right now again continue, if your rotation is continue up to 180 degree, up to 180 degree, if angle between these two bonds is 180 degree, this and this angle between these two CS3 is 180 degree. Two CS3 are 180 away from each other. These two CS3 are 180 away from each other. Now two bulky group, 180 away means completely away from each other. 180 away means completely opposite direction. They are present in completely opposite direction. So here of course this structure is a staggered one. This conformation is a staggered conformation, means groups are 60 degree away from each other. But in this case these two bulkier groups are 180 away from each other, means strain will minimize again as compared to this conformation. In this conformation the two CS3 are only 60 degree away from each other. Two CS3 are only 60 degree away from each other. Of course this is also staggered, this is also staggered, as we have seen in this case. Here this is also eclipsed, this is also eclipsed, but this one is a more stable because there is a H and CS3 are there. In similar manner here these two CS3 are completely away from. Here we have a CS3 and CS3 are closer. We have a this CS3 and this CS3 are completely 180 degree away from each other. So therefore strain will completely minimize and the structure will be stable, most stable structure, because strain energy will completely minimized. Here we can see the clear difference here, right? Clear difference here. In this case we can see here strain energy it is 0 and strain energy is given, that is 0.9 kilocalories per mole, and here strain energy is 0. It means that this structure is the most stable structure of butane, right? So this structure is known as anti-conformation. What is meant by anti? That is two bulky groups are completely 180 away from each other. This is known as Gauchy anti-conformation, and this conformation is known as Gauch conformation, because here of course there is a strain is minimized, but these two CS3 are 160 away from each other. So therefore strain is not minimized up to 0, So this is this, of course this is also staggered conformation, this is also staggered conformation. This is anti-staggered and this is Gauchy staggered conformation, and this is fully eclipsed, this is a partially eclipsed. Fully eclipsed means what? Two bulky groups are completely overlapped on each other. Two groups are completely overlapped on each other. So therefore strain energy will rise. So always keep in mind, if bulkier groups are closer to each other, strain energy will increase. Strain energy will increase. And if bulkier groups are away from each other, strain energy will decrease. Right. So all are conformations. Keep in mind, all are conformation. In some conformation, this conformation in conformational analysis, keep in mind the structures are differ in only energy. All structures are same. All structures are same, but these are differ in only energy. Their properties are same, all have the same properties, right? But keep in mind, only there is energy difference is there. Energy difference is there. If you look like them, look at them, all groups are same, right? Hydrogen is same, right? CS3, both two CS3 are there. याच्यामध्ये सुद्धा दोन CS3, याच्यामध्ये सुद्धा दोन CS3, याच्यामध्ये सुद्धा चार हायड्रोजन, याच्यामध्ये सुद्धा चार हायड्रोजन. काहीही फरक नाही. जर तुम्ही बघितला त्या दोन्हीमध्ये काही फरक नाही, फक्त कशाचा फरक आहे? एनर्जी. तर देर इज अ डिफरन्स इन ओनली एनर्जी. इन कन्फॉर्मेशनल अनालिसिस, कीप इन माइंड, so due to the change in angle, dihedral angle, so there is a variation of energy, variation of torsional energy or variation of this strain energy will be there with change in the dihedral angle. So always keep in mind, in case of configurational isomerism, we know that one configuration is completely different from the another configuration. If you see melting point of one configuration is different than the melting point of another configuration. For example, cis and trans. Cis is completely different from the trans, but in this case these all are same, but they are differ in just energy, and whichever is the most stable, right, whichever is the most stable, that having the, right, which is most stable, that having the less energy. So keep in mind, in case of butane, this anti-conformation, anti-staggered conformation is the most stable conformation. Keep in mind, anti-staggered is the most conformation. If you see the stability order, anti is the most stable conformation, then we have the Guacci conformation, then we have this conformation partially eclipsed, and then we have the fully eclipsed, right? This is the stability order. Energy order is reverse, right? Fully eclipsed, more highly energetic, then this, and then this conformation, that is anti-conformation. Now we'll see the conformational analysis of cyclohexane. Particularly, we have to focus on the conformational analysis of cyclohexane. Cyclohexane is a, right, simply if you see, look at this cyclohexane structure, this all hydrogens look like overlapped on each other. So this is the planar structure of cyclohexane, right? Cyclohexane having 6 carbon and 12 hydrogens. 6 hydrogens are above the ring and 6 hydrogens are below the ring. If you see in a planar ring, so all hydrogens are looking like they are completely overlapped on each other, like we have seen in case of butane or ethane, in which if hydrogens are overlapped each other or groups are overlapped each other, at that time strain energy of molecule increase. That structure is known as the eclipsed structure or eclipsed conformation. आपण त्याला म्हणतो, right? Here also we can see the same case. All hydrogens are look like eclipsed on each other, completely overlapped on each other. Of course, here in this case, right, the problem of the planar conformation is that in case of planar conformation, we know that for the tetrahedral carbon, right, for the tetrahedral carbon, we have a bond angle is, for tetrahedral carbon, bond angle is 109.28 minutes. That is the bond angle of tetrahedral. And here we can see this structure is a planar one, right? So 6-membered planar ring having bond angle is 120. Bond angle is 120. If you see this bond angle is 120. Bond angle is 120 degree in case of planar 6-membered ring. Actual bond angle for this, right, tetrahedral carbon, we know that bond angle for tetrahedral carbon is 109, right, 28 minutes. 109, 28 minutes. This is the actual bond angle for the ideal bond angle for the tetrahedral geometry, tetrahedral carbon. But here we can see that this bond angle is 120, bond angle is 120 degree, right? So there will be angle strain, right? So keep in mind, in this structure, in planar structure, there will be angle strain, as well as we can see that these all hydrogens are eclipsed to each other. These all hydrogens are eclipsed to each other. These all hydrogens are eclipsed to each other. So therefore what happens here, both strain will be there, torsional strain as well as angle strain. Torsional strain due to torsional strain or dihedral strain due to presence of these all hydrogens, right, overlapped on each other. And another thing, that is the 120 degree bond angle, which is not the ideal bond angle of the tetrahedral carbon, which is 109, 28 minutes, right? So there will be more deviation, positive deviation we can see from the bond angle, original bond angle. So therefore what happens, they actually, we can see, always we write the structure of the cyclohexane, but in case of cyclohexane the actual structure is different than this cyclohexane, right? This is the planar conformer of cyclohexane, from planar conformation of cyclohexane, in which we can see both the strain, that is angle strain as well as torsional strain, right? Torsional or due to dihedral angle, dihedral angle, due to dihedral angle, both the strain we can see, both the strain we can see, right? Here, due to this two strain, energy of molecule will increase, energy of molecule will increase due to this two strain. Now what happened, the cyclohexane, by the ring occurring, we can have this structure, that is chair conformation, that is chair conformation of cyclohexane. In chair conformation of cyclohexane, we can see that it is like tetrahedral, right? It is not a planar, it is a chair conformation. In chair conformation we can see that there is angle strain is minimized. Here angle is 120 degree, right? Here is bond angle is 120, sorry, bond angle is here 109, bond angle is 109, 109, 109, 28 minutes, 109, 28 minutes, which is the ideal bond angle for the tetrahedral geometry, tetrahedral carbon. Now here bond angle is minimized, bond angle is minimized. If you see its structure, right, in Newman projection, if you see this in Newman projection, the chair conformation in Newman projection, right? So this is the Newman projection of chair conformation, right? Bond angle is minimized, already we have discussed. Bond angle is minimized, already we have discussed this, right? In chair conformation is look like the staggered conformation. It is the staggered conformation. It is staggered conformation, means torsional strain also minimized, torsional strain also minimized. These two CH3 are 60 degree away from each other, 60 degree away from each other. So therefore this is the staggered conformation. So keep in mind, chair conformation of cyclohexane is, chair conformation of cyclohexane is staggered conformation, staggered conformation. In addition to chair conformation, we can also have the other conformations of cyclohexane, that is boat conformation, that is boat conformation. Another conformation is a twisted boat conformation, twist boat conformation, right? Here we can see in boat conformation, of course angle strain is minimized, angle strain is minimized. Angle strain is minimized in boat conformation as well as in chair conformation. But keep in mind that here this boat conformation of cyclohexane is in Newman projection. If you see, the boat conformation of cyclohexane is the eclipsed conformation. We know that eclipsed conformation has more energy as compared to staggered conformation, which have seen before, right? This is the staggered conformation. We know always staggered conformation has less energy than the eclipsed conformation. So therefore the boat conformation of cyclohexane is less stable than chair conformation of cyclohexane, because angle strain is not there in both the conformation. Angle strain is not there, right? Due to minimize the angle strain, planar ring is converted into different other conformation, that is chair conformation and boat conformation. In boat conformation means staggered new eclipsed conformation. Boat conformation means eclipsed conformation of cyclohexane, and chair conformation means staggered conformation of cyclohexane. Chair conformation means staggered. So therefore keep in mind, boat conformation is more stable because it don't have any kind of strain. Here the torsional strain is also minimized and angle strain is also minimized in chair conformation. In boat conformation, angle strain is minimized, but torsional strain, this dihedral strain, is remain as it is, because in boat conformation these hydrogens are overlapped on each other. This is completely eclipsed conformation. Therefore this is unstable, unstable. This is the unstable conformation in case of cyclohexane. Other than this conformation, other some conformations are also possible, like twist boat conformation, which is also possible, right? Also possible for cyclohexane. If we see in energy profile diagram of conformations of cyclohexane, so these are different conformations we have shown here, and their energy also we have shown here, right? So this is the chair conformation. As you can see, as usual, the chair conformation has lowest energy. Chair conformation has lowest energy because it don't have any kind of strain, right? Next we'll see boat conformation and twist boat conformation, right? Boat conformation and twist boat conformation. In case of boat conformation, now half chair conformation, directly chair conformation cannot convert into boat conformation. Initially chair conformation converted to half chair conformation, and then twist boat, then boat conformation by rotation of angle, by twisting out ring, hook ring, we can convert from one conformation to the another conformation. You can see in energy profile diagram, half chair is the highly energetic conformation. Half chair is highly energetic conformation in this energy profile diagram. Then we have, right, then we have the boat conformation. Boat conformation is another reason for the boat conformation to be unstable, that is a flagpole interaction, right? Flagpole interaction is the another reason for the instability of boat conformation, and that flagpole interaction will going to minimize in case of twist boat conformation. So therefore twist boat conformation has slightly less energy as compared to boat conformation, so keep in mind, if you see the energy order here, the half chair is highly energetic, then the boat conformation, then twist boat, and this least energy conformation is the chair conformation. So therefore energy and stability relation, we know that as energy increases, stability decreases. So highly energetic conformation is least stable conformation. So if you see the stability, chair is more stable, chair is more stable than the twist boat, right? Twist boat. Then we have boat conformation, and then we have the half chair conformation, half chair conformation. So this is the stability order. This is the stability order: chair, twist boat, and half chair conformation. This is the stability order. This is the energy profile diagram, conformational analysis of cyclohexane. Thank you.